हरिः कन्ना।
So now let's look into the final module of intuitive plots for you course. This would be more fantastic. Fantastic. It would be, it's like fun tasks. We'll have a lot of fun tasks. You will surely you will enjoy this module. We'll be drawing and plotting 3D pictures or 3D plots or 3D graphs. So you would be enjoying. So 3D plots using the MPL underscore toolkits dot mplot 3D library. This is what we are going to use here. So I'm just repeating it one more time. MPL underscore toolkits dot mplot 3D library. So this is what we are gonna use here. So let's begin with the 3D scatter plot. What is a 3D scatter plot means? 3D scatter plots are used to plot data points on a three axis in the attempt to show the relationship between the three variables. So each row in the data table is represented by a marker whose position depends on its values in the column set on the x, y, and z axis. A fourth variable can be set to correspond to the color or size of the markers, thus adding at another dimension to the plot. So the relationship between different variables is called a correlation. If the markers are close to making a straight line in any direction in the 3D dimensional space of the 3D scatter plot, the correlation between the corresponding variables is high. If the markers are equally distributed in 3D scatter plot, the correlation is low or zero. However, even though a correlation may seem to be present, this might not always be the case. The variables could be related to some fourth variable, thus explaining their variation, or pure coincidence might cause an apparent correlation. So you can change how the 3D scatter plot is viewed by zooming in and out as well as rotating it using the navigation controls located uh, in the right portion of the visualization uh, that normally it consists of. So let's make one a plot and let's look into the plot now. So 3D plots. Yep. So let me create one more. Save this. Yeah. 3D. So the first one is a 3D 3D scatter plot. So let me import matplotlib dot pyplot as plt, then import numpy as np. So then let me take a package plt dot style dot huge of underscore mpl gallery. Yeah, I think fine. Yes. So now let's make the data for that. So np dot random dot seed of 1968 1968 0801. So, and we'll take n, a sample is 100, 100. Then rng is the variable random number generator. Random number generator is equals to np dot random dot default dot rng method. Then let's start building. Let's start creating x is equals to rng dot. Obviously, I'll go for the uniform. Okay, random dot default rng. Okay, rng dot uniform 23 to 32, and then n sample that we have mentioned earlier that you can see on screen. Then ys is equals to rng dot uniform of 0 to 100, 100, and then space n. This is ys, and let's go for the zs. And again rng uniform of -50 to -25 to n. So that's it. Our x, s, y, s, z, s all are ready. This is our axis, and this is our ys, and this is our zs. That's it. So let's plot now. Let's plot the 3D scatter plot. So fig ax is equals to plt dot subplots and subplot underscore kw is equals to, I'm going to use a keyword. It's a projection. Which projection I want? Obviously I want 3D. So 3D subplot. Yes, here is that. You got your 3D projected subplot on your screen. Yeah. So now let me add ax dot scatter. So xs comma ys comma zs. Here is the plot. So let me add labels to that. At this moment I don't need to add any label, or if you want to add labels, you can add labels. Just say ax dot set. Inside the set I am gonna say x tick labels, and y tick labels, and z tick labels. So if you want to mention anything, you can mention, just leave it like that and say plt dot show and execute, and here is your plot. And yeah, this is what is your plot. You can see that as we have discussed earlier, these are spreaded across, so the correlation is low or zero, completely low or zero. Either there is no specific line formation, or there is no trend that we can see here. Okay, so there is no, I think we can consider it as zero correlation.